So what do we do when we have logs on both sides of the equation, and then we have this pesky number 1 here that seems to be throwing things off? Remember, your strategies for solving log equations was to isolate and condense the logs. So we got logs on both sides, so maybe I want to get all the logs on one side, so we're going to isolate. So what we'll do is I'm going to move everything to the left that has a log, so we're going to subtract that log 5 of x minus 1. So that's what we're going to do. So we're going to subtract it from both sides, and we'll rewrite it. So we have log 5 x plus 2 and minus log 5 x minus 1, and that's going to be equal to 1. And now what I can do is, now I have both the logs on the same side of the equation, and they're the same base, so I can go ahead and combine them or condense them using the quotient rule. So we're going to go ahead and do that. So we'll combine our logs. So if it's positive, it's upstairs, negative downstairs, and we're almost home free with this one. That's equal to 1. Alright, so we had two different types. We were going to have either log equals log, and since the log's 1 to 1, we can drop the logs and just equate the arguments. Or if it's log equals a number, like what we have here, alright, we go log and then it's exponent number. I'm sorry, I said it wrong. It is log base number and then the exponent. Our base here is 5. Our exponent is 1, and that's equal to the argument of x plus 2 over x minus 1. And we'll just go ahead and rewrite this on the next page, and we'll go ahead and solve it. Okay. And then you're home free. This is just a linear. So what we want to do is we want to clear the fraction. So we're going to multiply both sides by x minus 1 to clear that fraction. And we'll go ahead and distribute the 5 through. So we have 5x minus 5. And that's going to be equal to x plus 2. And then we're just going to move all the x's to the left. So we're going to add 5 to both sides and then subtract x from both sides. And we will have 4x is equal to 7. And we'll divide both sides by 4. And we'll get x is equal to 7 over 4. Now what I did not do is I didn't go and look at my restrictions. Well, we can look at that right now. One of the arguments was x plus 2. And we want that to be greater than 0, so x needs to be greater than minus 2 is one of my restrictions. The other argument was x minus 1 needed to be greater than 0, so x had to be greater than 1. And that's the more restrictive of our restrictions. It's more restrictive to be larger than 1. 7 over 4 is certainly larger than 1, so this one is a good solution.